Hello, dear students. Welcome to Math Eyes, organized by the Gym Foundation. Ever wondered how people like Srinivasa Ramanujan, Carl Gauss, Euclid, or from the ancient times Aryabhatta or Varahamihira have developed into great mathematicians? It's not a miracle or a magic, and more than that, they have honed their eyes to become a math eye such that they see patterns where others see only numbers. And they find connections between something which are totally unrelated. And also, they turn everyday observations into mathematical questions asking what if and why. And so they are able to find some mathematical idea even behind a simple situation, like just noticing a flower or seeing some rabbits or even composing a music. So, this way, they could connect different ideas and discover many original ideas on their own. This is how many mathematicians got blossomed. And through this event, we are aiming to make every one of you participating in this to think mathematically and through two different prompts that we provide. One is the number prompt and another is a picture prompt. So as you could see, the number prompt will have some numbers in it, and it's not just numbers that you're going to see, but you're going to do a routine, thinking routine called notice, wonder, think. So as part of notice, we are going to see, is there any relation between the numbers here? Can you spot any patterns? Can you make any small observations that you can? So you can submit your notice, observations, and in wonder, you are going to ask some questions on what if I change something like this? Can I see any number property within this? Can I make some changes on that? So basically asking some questions on your own, which you want to try in this prompt. And think is to extend that just question and work on it a bit more to come up with some interesting plan or a concept that you can apply and get a possible approaches or solutions for the question that you have posed on. So this is the framework of notice, wonder and think that we'll be going through this math ice session. And in this session, we are going to do it together on what are the things that you can notice from this prompt and wonder and think about. Are you ready? Come on, get along with a paper and a pencil so that you can do on your own as well. So whenever you want to kind of think about a prompt, which is in this case just a number prompt, it would be good if you are actually having some way to understand this prompt. So let's start with some notice. For example, what do you see in this prompt? Okay, so like you all might have mentioned, it is more about having 12 times 2 is 24 and 6 times 4 is also 24, right? Okay, so then you can write it like this. 12 times 2 is 24 and 6 times 4 is 6 times 4 is also 24. So what is special with these four numbers? This is a main observation that on the left hand side and the right hand side both are same. Yes. Is there something more to specific about these numbers? So whenever you are planning to actually understand something deeper, it is good to ask some guiding questions. For example, how are these numbers on the left hand side and the right hand side are related? So that's a good question to ask with. So how are these related? So can you see the number 12 and 6 and the number 2 and 4? So can you pause for a minute and see, is there any relation between these two? So pause here and think for it a minute. Okay, so I hope most of you might have noticed that here in this case, when you divide 12 by 2, you get 6. Yes, so dividing by 2, you get 6, and multiplying 2 by 2, you get 4, right? So that's a good observation, pat on yourself. So you could see the first number, when you divide, you get the second number, and then the number on the right, and then for it to be equal, for the statement to be equal, then you need to actually multiply the second number by the same number which you are divided with to get 4, which is makes the statement equal. So what are the other things you can try? So you can think, oh, will this hold for any other numbers, or is it just only for these four special numbers? So can you pause and try taking a new set of numbers and check it out? Okay, so for example, let's take another number like 20. So you can say 20 times 3 is 60, right? But if I want to make a equal statement, I need to divide this number by something. So for example, let's take I'm dividing 20 by 4. In this case, I get 5. So our observation says that I should multiply the second number by the same 4. So multiply by 4. So 4 times 3 is 12. So 20 times 3 is 60 and 5 times 12 is also 60. Oh, so it seems that your observation is actually working for other numbers too. So that's good. So what else could you think of? What other numbers would you like to try? The basic idea lies in what are the different numbers and the variations that you can try so that you get a very solid idea about it. So would you think that in all these cases I am taking the number which I am dividing or multiplying, is the dividing is a factor of this number, like 20 I am taking 4, I am not taking 6, right? So what happens if the number is divided by another number which is not actually a factor? So for example, in the case of 12, what happens if I am dividing 12 by not by 2 or 3 or 4, but by 5? So 5 is not a factor of 12. So if I divide 12 by 5, I get the answer as 2.4. Yeah. So what would happen if I multiply the same 2 with 5? So for example, 12 divided by 5 and then multiplied, this number is 2 multiplied by 5, right? So you get 12 times 2 is nothing but 12 divided by 5 is 2.4 and 2 multiplied by 5 is 10. So 2.4 times 10. So 24 and 2.4 times 10 is 24. Oh, then it holds true. So it is not only for factors of the number, but you can take any number other than the factor that also works. So this is how you kind of analyze different numbers to understand the prompt better and make good observations. So now let's go to the next part of wonder. So the first wonder question might be, why does this simple, like the division or multiplication works? Why does this simple observation works that way, right? And what would happen, for example, if the multiplication is actually not multiplication but replaced by addition? So on that case, how would it work, right? So I'm not doing multiplication but I'm doing addition, but how the both statements can be true? On that case, what should I do? Or for example, what would happen if the multiplication is replaced by not addition but subtraction? It's a bit different operation as such. So what would happen if it is subtraction? So this is another wonder question that you could come up with. Or even you might think that, okay, let me have the same multiplication, but instead of doing division and multiplying the inverse operations, can it work with addition and subtraction? For example, retain multiplication, and then instead of dividing and multiplying with same number, can I add and subtract with some number? So can you do that? So that's also a very interesting question you can ask. So these are some of the questions which will help you widen your thinking and also understand this concept better. So with this wonder question, let's go to the think. So why this simple observation, whatever we made here works? Like 12, if you divide by 2, it is 6, and 2, if you multiply by 2, it works, and both are same. Why do you think it works? Can you pause and think on your own? Okay, so if you have something to share, please do share in the comments. Let's take with an example of what's happening here for the first question. So 12 times 2, and you are dividing the first number by 2. So how can I write this? So 12 divided by 2, and then you are multiplying the second number by the same number. Correct? So this is the actual thing happening here, and when you actually write this as numbers, you get 12 divided by 2 is 6 and 2 divided by 2 is 4. That's what you have written here. But also, if you see, what are we doing essentially? We are dividing a number by 2 and multiplying the number by 2. So basically, what happens when you divide and multiply by same number? It is exactly multiplying by 1, right? So, or in other words, we would say you cancel these two numbers. So essentially you get the same number, right? So this is another way of telling you divide and then multiply by same number. So this is why the observation works. So now let's see what happens if the multiplication is replaced by addition. This is a very important thinking here. So for example, if instead of doing multiplying, if I'm adding 12 plus 2, what would happen if I want to have a same equation on both sides. So what should I do if I want to have 12 plus 2 is equals to something plus something? So as you can see here, this multiplication and division are inverse operations, and doing that you get the same number, like multiplying by 1, which does not change the result of the product. So here, what should I do? Should I actually add and subtract? So if I add and subtract, let's see what happens. So 12 plus 12 is 14 and 2 minus 2 is 0. So if I add and subtract, then what happens? You are adding 0. So this is called identity property. So in multiplication, you multiply by 1, it is identical. If you in addition, if you add 0, it is identical, right? So 12 plus 2 and you add 2 minus 2, this becomes 12 plus 2 is 14 plus 2 minus 2 is 0. It remains same. Yes. So let's take another number and check for ourselves. So let's take any number you can take. So 18 plus 6 and maybe add 3. So 18 plus 3 is 21 and 21 plus 6 minus 3 is 3. So both sides are 24. And should it matter if I add and then subtract, or can I subtract and then add? Yes, you can subtract and add. Let's see. So instead of adding here, I will add on the other side. So 18 minus 3 is 15 plus 6 plus 3 is 9. So all of them are adding up to 24. So when you actually do an addition in the middle, you have to add and subtract, and therefore the number expressions on both sides of the equation remains the same. Yes. So now let's go to the subtraction. So this is a very interesting example with subtraction. Let's go to the third point. So if I subtract 12 minus 2 is equals to what minus what? So in this case, let's see again. Can I add 2 and subtract 2? Just what I did for the addition. We can check. So 12 plus 2 is 14 and 2 minus 2 is 0. But 12 minus 2 is 10 actually, and 14 minus 0 is 14. So they are not equal. So by adding 2 to the first number and subtracting 2 from the second number, it is actually not working. It's not true. So what would you try next? Maybe like this what we did. We will subtract 2 first and then maybe add 2 on the second number. So let's try doing it. So I will subtract 2 from 12 and then add 2 to the second number. So then 12 minus 2, in this case subtract 2 and then add 2, it would actually mean 10, and 2 plus 2 is 4, 10 minus 4. So 12 minus 2 is 10 and 10 minus 4 is 6. They are not equal. So both the ways which worked for addition, it did not work here. Can you guess why it is not working and what you can do to make it work? Pause for a minute and think. So here, what did we actually do? We added and subtracted, and that resulted in the 0. Adding and subtracting same number resulting in 0. What do you think will happen or we should do to get some number minus some number is 0? So if you add 2 and then you have a subtraction here, and then so you are adding 2 and subtracting for another number, what you should do to get it as a 0? So now what we tried is, here I added 2 and so here I am subtracting 2. So as you could see, the number actually becomes 2, negative times negative is positive, 2 plus 2 is 4. So the number gets added by 4, and that's why if you see here, the difference is always 4. 10 plus 4 is 14, 10 plus, 6 plus 4 is 10. But what we actually should do is, we should add same number on both sides to become 0. So shall we try that now? Okay. So here you go. When you have 12 minus 2, you just add 2 on both sides. So what do you get? 12 plus 2 is 14 and minus 2 plus 2 is 4. So let's see, what is 12 minus 2? It is 10. And what is 14 minus 4? It is also 10. Oh, now it works. For the case of subtraction, you need to add the 2 on both sides. Let's take some other example. For example, 18 and 6. So 18 minus 6. So let me add some number like 3 or 4. So you add 4 on both sides. So 22 minus 10. Right? So 18 minus 6 is 12 and 22 minus 10 is also 12. So true. So now what we did is, we understood that by identity property, we can get both sides of the statement to be true. So when you have the multiplication, the inverse operation of division and multiplication will get same values on both sides. Or in the case of addition, inverse operations of adding to and subtracting the same number will get you a balanced number expression. But in the case of subtraction, you have to add the same number on both sides, or both the numbers on the expression, to get a equal expression, another equal expression. So there are many more things, such things to actually wonder, think about. And it would be really very nice if you have any interesting observations or wonder questions or something that you have found on your own. Please do share it in the comments or to the mail ID, thegymfoundation@gmail.com. Thank you, students. Looking forward to your interesting participation for the poster that would be published for August 2026 Math Ice. Thank you.